Welcome back, ladies and gentlemen. Nice to have you with us for our next in-depth session, which will consider the energy transition. Of course, transition means something has already started. We go from one point to the next, and it is always this crossover phase, which is both interesting, but it's also a question of how to do it. So when we talk about climate neutral aviation in 2050, we don't talk about if, we talk about how. And of course, I'm not going to be the session chair. I'm going to introduce him last, but I'll introduce the panelists that you are going to hear from. And nice thing is we have a number of people on stage, but the first person I'm going to introduce is from the company Pipistrel in Slovenia. Pipistrel apparently is normally the name of a bat. So welcome to the Batman, the founder and CEO, Ivo Boscarol. So wonderful that you are with us. The second person that I may introduce now is from Leonardo in Italy, the head of advanced research, Marco Protti. Benvenuto. And we'll go on with one of the people actually live here on stage. And I can say hello to Siegfried Knecht, who is from AREG. That's the Aviation Initiative for Renewable Energy in Germany. 9 years already on the road and more in demand every year. The fourth person is remote, Rob Watson. He is from Rolls-Royce, the director electrical. Then we continue with the MTU Aero engines, the head of innovation management, Jörg Sieber. I suppose hello to Munich. And last but not least on stage, but not the last person on stage, is the senior aerospace executive. You may know him from Bombardier, Lufthansa, Airbus, Rolls-Royce, you name it, he's been there, but he's now on stage with us, Nico Buchholz. Last but not least, and that person you've seen a number of times yesterday, so I'm very, very happy to introduce the session chair as the representative aviation of the executive board of DLR and vice chair of the advisory council for aeronautics research in Europe, Professor Rolf Henke, and we're going to do something unusual because we're both on stage. I'm going to step back, Professor Henke is going to step forward, and you can now start the session.
Thank you very much. Thank you very much, Connie. Well, I'm glad to be here, and I'm also glad that at least we have two of the speakers with us. I would be even more glad having all of you here. Anyway, now we start. So I would start with a small presentation and maybe already include some provocative questions and then hand over to the procedure speakers. If I start with my talk first, energy transition, just as a side note, energy transition is what engineers always do, isn't it? But here we talk about, of course, fuel and other things. Oh, I press the button. I say, next, please. Okay, here we go. It's hardly to be read anyway. You see on the left-hand side in the box everything what we have today, today's aviation with aircraft, small ones, regional jets, even helicopters, all relying more or less on gas turbines and Jet A1 fuel. And on the right-hand side is a sort of toolbox we now have with everything that is new for this energy transition. If I start in the 3 o'clock position, hydrogen, H2, for gas turbines, direct combustion. We heard about it already today and yesterday. Next one in clockwise direction would be batteries. No, stay with that picture, please. We have the sustainable aviation fuels for AREG and others. We have new aircraft configurations we've seen recently and just from Airbus, 3 new ones. Climate optimized routing, I think one of the biggest things we can do in the future. We have fuel cells, again, of course, linked to hydrogen. New system architectures for the vehicles, but also for the aviation system. And finally, new ways of flying, like formation flight and others. This is sort of toolbox we now have. And if I may have the next picture. Now we can use this toolbox for the future of aviation. It probably will start with smaller aircraft, and there we can check out very many things on batteries, on fuel cells, flying fuels, etc. And then step by step go until we reach the long-range aircraft. Maybe this will be the hydrogen one in 2050. In general, what you see on the top right, I think from the growth, and we have really stable growth for more than 30 years, 3 decades, we're now in the transformation of the aviation system for the next 3 decades until we have the Green Deal in 2050. So that could be the future, and the future may be long range with hydrogen. Next, please. This is a very famous picture from on climate research. What it shows is the cooling and warming effects of the different impact factors in aviation. And just on top you see CO2, and you see also that it's just one impact factor, and there are a couple of more, NOx, water vapor, sulfur, and etc. Almost 65% of the aviation climate effects are non-CO2. So just 1/3 is CO2, the 2/3 are non-CO2. And you see H2, hydrogen application, will not prevent from all of these non-CO2 effects. You see the arrows on the left-hand side. So what's coupled to H2, if we burn it with the atmosphere, we will have NOx. We have water vapor, we have contrails, induced cirrus, contrail cirrus, so there will be a couple of influences and impacts, even if we use H2. I'm in favor of everything, but we have to keep that in mind and find a solution for it. Next, please. So there are a couple of papers around, and we have seen some of them yesterday, introduced them yesterday. We have the hydrogen-powered aviation strategy paper from joint undertakings, FCH and then Clean Sky. We have in Germany the national H2 strategy. We have the hydrogen strategy of the Commission. Applications of hydrogen is by no means is new. I mean, even the first balloons some 200 or 300 years ago flew with hydrogen, the first Zeppelins flew with hydrogen. We now see many European papers. The question is, are we on a hype curve, which you see the famous one on the top right. Are we there? And that would be a danger, because then we could inflate the expectations from hydrogen. We have really to keep in mind there are a couple of problems around it. So it's not salvation from all aviation problems. We really have to work on that. And there's a couple of things to do in research. New approaches, we have on the left-hand side present strategy papers. You see the, I hope, famous Flightpath 2050 paper, the vision paper of the European Commission for the world of aviation. On the bottom left, you see the strategy paper of our federal government in Germany, and there are similar papers in the other nations, in France and Netherlands and everywhere else. We have research programs, large funded research programs, and on the middle side. So they see the LUFO, the Luftfahrtforschungsprogramm, the federal research program in Germany. You see ATI, we heard about it already in this round here in UK, CORAC in France. And this technology programs lead to a permanent flow of technologies, what I call it. So its improvement is roughly 2.5% per year. That's what we get better. When we now see some newer and more recent papers, Zero Emission Aviation, there's an opinion of a German aerospace society, GGLR, together with the French Academy of Aerospace, and asking for more and a different way of thinking. So I believe that we need not only funding for new technologies, but also we have to think about the funding rules, think about demonstrators, maybe even prototypes. So we have a couple of things ahead of us. Now we are in this procedures panel. See again what Conny already introduced, our speakers, our 6 speakers, Boscarol from Pipistrel, Marco Protti from Leonardo, Siegfried Knecht here with us from AREG, Rob Watson from Rolls-Royce, Jörg Sieber, MTU, and Nico Buchholz also here on stage as a senior aerospace executive. And I would like to start with the first question to Ivo Boscarol, and he will give us a short presentation. The question would be, with Pipistrel being a forerunner in electric flying, what are your current plans and which are the big challenges ahead of you? Ivo, please.
Thank you very much. Yes, let's start first of where we are in general. So we are all talking about the atmosphere today, about the energy transition. But, you know, if you see the Earth from the space, you will see a tiny blue belt around it. And this is our atmosphere. We can live months without the food, weeks without the water, but only a few minutes without the air. So to keep it as it is, we must speed up the transition time to climate neutral aviation. But unfortunately, it took us 68 years after jet engine aircraft was type certified to a new milestone in aviation propulsion, because the next milestone was made only this year when the first electric type certified zero emission aircraft was, let's say, certified. So we must speed up this energy transition. It's a duty of all us involved in tomorrow's aviation to develop and implement new, innovative and revolutionary technologies which lead to emission-free aviation and reach the set objectives. This means to assure to the community better living environment. Pipistrel is a proof that also SMEs with limited resources can contribute to climate neutral aviation. We have been producing electric aircraft since 2007, and of course, we will produce them also in future. I can assure you that in 2050, Pipistrel will be producing only emission-free and climate-neutral aircraft. But we all together, we must give the message to the industry that emission-free propulsion in commercial use is now possible and the right way to go forward. We must change also, sorry for this. We must change the mindset of the people. To reach the objectives, a lot of homework has to be done in the complete ecosystem. The transport is still organized in a non-efficient way. To reach the final destination, we must still exchange too many time-consuming. I see that the slide is not the correct one. Sorry. The slides are not following me. Oh, yeah, okay, I see. It's slow, this button, sorry. Nowadays, we are bringing passengers to the airports, which is wrong. It should be the opposite. We are destroying the best agriculture land to build large airports. We need a new concept which will bring the airports closer to the passengers. Transport in the next decades must be also regional transport must be legalized also on small airports. But because of the increased population, better travel comfort and safety standards, the existing the transport is increasing every day. Therefore, the existing mostly two-dimensional concept of transport is not efficient enough anymore. We must benefit from the third dimension and we must move travels and transport into the air. We have only one way forward. All the participants must step together and the result must be reached. If we don't reach the results and we all work in one direction, will not help. The atmosphere needs the action immediately. European Green Deal guidelines are to be implemented to reach the needed and desired results and must be followed also after 2030. By type certifying electric aircraft, Pipistrel opened the doors towards commercial use of electric aircraft. Now, worldwide regulatory institutions must work hand in hand with stakeholders. I believe that automotive and aviation industry must cooperate in this process. Automotive industry must bring its standards closer to aviation ones, and aviation industry must adopt the advantages of the lean and mass production to make tomorrow's transport industry stronger and more profitable to meet the needs of citizens. Pipistrel will contribute to this, but of course, we need the base, and the base, not only Pipistrel, are set by regulatory institutions, and we need the help of all of them.
Thank you very much for this very engaged introduction by Pipistrel from Boscarol. Next goes to Marco Protti from Leonardo. Leonardo has been working for quite a while in Clean Sky on electric and hybrid electric regional aircraft. So what do we achieve so far and what will be the next steps? Please, Marco Protti.
Thank you. First of all, I want to share the thanks to all the organization to give me the opportunity to contribute to this discussion, recognizing how big is the challenge that we are facing, but also which big opportunity the step versus the climate neutral aviation provide to our ecosystem and the appropriate way to follow this line. Next, please. This is the well-known picture in which the message that we have to capture is that what we are doing in the traditional incremental evolution of the technology maturation to support a more safe, competitive, and less polluting aviation is not enough to satisfy the challenge that we have in front of us. We need to have a step change. We need to take a different approach compared to what we have done since 2007 in Clean Sky 1 and Clean Sky 2. Next, please. We need to have a systemic approach in which we look to the full chain that provide at the end a safe and economic and sustainable air mobility for the benefit of our society, but fully compatible with the climate of the Earth, that is the only one that we have to use. And there are four main areas that we have to address in a combined way, to address accompanying the transition across the standard way in which we are now managing the air mobility to a completely different approach that at the end comply with the basic requirement that air mobility have to satisfy in order to be an effective solution for the society. Next, please. In doing that, we need to recognize that this is also an opportunity for our arena in order to bring in new market opportunity to mature product that can be different from the ones that we have now in our portfolio. And the example provided by Ivo before is just a good one. But we go even beyond, because in this transition we can take on board new stakeholder that is not typically inside our ecosystem, but that we need to bring in order to exploit the capability. And finally, we have in front of us new mobility service that we can provide to the society to improve the quality of the service that we deliver at the end. Next, please. But we need to recognize that we have some challenge in front of us, because we plan to use a quite different class of product, and we need to overcome some barriers that come from different business model by the need to rediscuss some certification path that we usually have in mind, that we need at the end, in any case, to deliver competitive solution for the air mobility from not only the production of the new aircraft, but also the capability to support them. And all that, of course, while we are maturing a completely new set of technology that are necessary to implement this solution. Next one. And so we need to start a roadmap well integrated that from the maturation of key enabling technology, at the end will deliver new air mobility solutions that include not just the aircraft, but all the chain from the production of the fuel to the delivery of the fuel to the airport, to the capability to operate safely the new type of product, and at the end to deliver the air service at competitive price to the society. Thank you.
Thank you very much. So next goes to a colleague already with me in this room here, to Siegfried Knecht from AREG. And the question is, how do you see the opportunities and threats to introduce in short-term notice, sustainable aviation fuels?
Thank you very much, Rolf, and I'd like to thank the organizers for an outstanding summit, which, as you probably heard already, tackles challenges, but also possible solutions to protect our blue planet. Well, AREG, as already being said, is the Aviation Initiative for Renewable Energy in Germany, and if you like to learn more about us, there is a slide at the end of my presentation, which I'm not going to refer to, or I invite you to visit our homepage. You've seen this slide, I assume, 1,000 times, and it was also shown a couple of minutes ago by Marco. What I'd like to emphasize here again is the light gray part of it. Of course, we all know there will be disruptive aircraft technologies available within the next 1 or 2 decades, but I or the AREG members are convinced that a major contribution will come or needs to come from SAF, from sustainable aviation fuels. Today, today there is only little SAF available. You know, there are very few companies producing kerosene today. World Energy in the US, Neste in Europe, just to name 2 of them, of the very few. But I would say there is light at the end of the tunnel because we learned recently that those engaging in the production of sustainable aviation fuel will probably make available around 10 million tons by 2030. And in addition, I also recently learned that basically there is enough feedstock available already today to comply with the amount of kerosene needed by 2030. Of course, the feedstock availability is one thing, production is a different story, and so we need to see how this is going to evolve. But I guess we all need to take into account all the technology pathways and not only look, as this is apparently being done in my country, only to the power to liquid pathway, because that's being made available only, let's say, in significant amounts beyond 2030. As you know, there is always that chicken and egg problem. Producers are asking airlines, you know, to use the fuel, and airlines are claiming, well, that's far too expensive. So there need to be legal measures, and I assume you're all aware there is a big discussion, not only in Germany, going on mandates. There are mandates, you know, around Germany, either on a legal basis or on a factual basis in the northern countries, but also in the Netherlands or in France. And I would say that's one means, you know, to provide incentives for producers as well as for consumers. And again, you were listening a couple of hours ago to the global aerospace CTOs. They recently sent a letter to the ICAO General Secretary claiming again that there is enough feedstock to comply with the kerosene needs by 2050. I sometimes tend to speak not about decarbonization, but about defossilization. And I bought this last slide from my friends in Neste, which shows, you know, what the challenge is. Today, you know, that blue rectangular, you know, indicates the consumption of fossil oil today, and the red dots, that's the increase by 2030. The white one, as you can see, is the amount of electric cars, you know, today in operation, and being probably around 150 million electric cars in 2030. Then you see, you know, the production capacity of Neste and the increase by 2030. And the light blue one, you know, is the global jet fuel consumption. So that's the challenge, you know, we have to cope with. We need to defossilize not only aviation, but the entire industry. And AREC, at least I hope, can make a contribution to this challenge. Thank you.
Yeah, thank you very much. It was a very good insight on where do we go with sustainable aviation fuels. Now we have two engine manufacturers. We start with Rob Watson from Rolls-Royce. And the question would be that as a propulsion provider, what challenges do you see in helping to realize the different visions which are already mentioned, like electric, hydrogen, SAF, and others? It's just you're connected by phone, so we see your photo, but now please give us your presentation.
Thank you, Professor Henke, and thank you very much for inviting me today. I'm sorry I'm not there in person, and I'm sorry I'm not even visible. It's a COVID challenge for IT in the area where I live. On my second slide, we just highlight some of the themes that the other speakers have already mentioned around the prospects of a green recovery. I think certainly for Rolls-Royce, we've had a significant impact from COVID because of our position in the long-haul market. And certainly when you're trying to transport hundreds of people, thousands of miles, there's always a challenge around how we drive sustainable aviation and opportunities. Actually, on slide 3, in Rolls-Royce, we talk about our environmental strategy for aviation, and it has 3 pillars. Obviously, I think we have a very strong market reputation for constantly investing at scale in driving the efficiency of our core gas turbine products. And I think everything the panelists have said so far reinforces that message that really we will need gas turbine capability for years to come. And the question really is, can we accelerate how we improve the environmental performance of those gas turbines? So as long as alongside investing in more efficient gas turbines, and obviously you've also just heard from Siegfried around the opportunity around sustainable aviation fuels, which will be a major point of focus for us too. You know, we would also say that in our view, you know, the quickest way to make substantive progress is really to focus on SAFs, because that seems to be the most pragmatic way to address the challenge while still enabling the global population to connect in the way that it connects today. But of course, we're also a global technology company, and my particular focus is in looking at those disruptive third generation technologies. And here, I think particularly the focus on electrification and what that may enable, and obviously over time hydrogen, become really important. I think just on slide 4, I think I'll only touch on this very briefly. Obviously, you know, we have this focus on sustainable aviation fuel. We'll be testing a SAF on one of our engines shortly, and that will be 100% SAF. In the past, we've demonstrated some at a 50% blend, but we're really pleased to announce that we're accelerating our progress here to help get moving. But I think also, as Siegfried said, that the challenge is also around what's the availability of feedstock and what's the actual requirement of SAF over time out to 2050. And it is a significant number, and we will need to think about multiple ways to develop that fuel of the future. But for me, on slide 5, it's really all about the disruptive technologies. And in Rolls-Royce, we've been looking at how we can bring our capability to bear to drive different options to push for sustainable aviation. Electrification, as Ivo has said, hugely exciting and some great opportunities, both by driving hybridization, which I think gives it range and capability quickly, and full electric capability. Those pictures you can see on the left-hand slide, we're really proud to be supporting Airbus with the City Airbus demonstrator program, and we're developing our own hybrid system which could run in hybrid or full electric mode. And in the middle of the slide at the bottom, you'll see the Airbus I-5 aircraft, which we're planning to fly in the next couple of years, which will demonstrate the benefits of that hybrid and electric capability. Obviously, in recent years, we've been very proud to partner with Airbus around the EFAN-X program, which has taught us so much about megawatt scale electrical propulsion requirements. And over time, in our core markets, we're fascinated to see how the various different technology initiatives can help drive different solutions around sustainability, all the way through to that really exciting vision of the future that Airbus posted around possible new platforms which could exploit hydrogen in different formats. So a really, really exciting time, and Rolls-Royce, as you'd expect, positioned across all of these technologies to see how we can help support the drive for sustainability. But I think on slide 6, my concluding comments are really around these critical issues for consideration. It's always exciting to talk about technology, but we also have to understand how we deliver a meaningful commercial outcome, frankly. So we really do need to understand, how do we see these roadmaps emerging? We talk about targets in 2050 and 2030, but what are the actual steps that the industry needs to progress through to deliver a product? How fast can we go to address some of these changes? And what is the true scale of the investment required to deliver this? Are we ready to invest sufficiently to drive the opportunity? And I think at the same time, there is also a challenge. We talk a lot about the ecosystem, an enabling ecosystem, as Ivo described so brilliantly, how we should rethink travel. But also we need to think about the ecosystem in terms of how we deliver the technology. The supply chains don't exist today for some of this. It's very hard to create this new industrial capability. So alongside the focus on how quickly can we demonstrate something, how quickly can we move to a prototype, how quickly can we scale industrial capacity to help us realize the vision. And then a further challenge that I think we have to be thinking about today is commercialization. And again, some of my esteemed colleagues have already mentioned this point. Operators today want to see a new technology where the acquisition cost it's cost neutral to introduce this technology to a platform. And alongside that sustainability delivery that you give, what about the operating cost? How do you drive down operating costs? How do you make this commercially irresistible to the market? And there's some huge challenges around there about how you translate technology into products that we need to recognize. I think it's really exciting to talk about the opportunity, but we have to commercialize it for it to be successful. And I think we have to stay focused on that element of the discussion. My final point was simply around how successful can we be? How far can we go to drive to net zero emissions, emission-free flight? It's a hugely exciting opportunity to drive sustainability. But for me personally, inside Rolls-Royce, the question is not simply can we see a route through the roadmaps to deliver the technology? Can we commercialize the technology? Can we industrialize the technology and really be confident we can deliver this change? Because it is an amazing opportunity for us. And those really were the points that I wanted to leave you with. So thank you very much.
Thanks, Rob, for this first round of the two engine manufacturers. And the question to Jörg Sieber from MTU must be the same, of course, in the first round. So the same question, as a propulsion provider, what challenges do you see in helping to realize the different visions already have been mentioned? Mr. Sieber.
I want to focus more on long-term aspects in answer to the discussions we started develop towards emission-free, which are today. First step, of course, that we will further develop our EX turbofan, which will deliver generation about 10% in production in CO2, but that's not enough. We have to do much more. And therefore, I want to present to you our big steps forward with the slide. I can't see my slide. Oh, yes. Okay, so first slide. The most efficient thermal combination of the gas turbine and the heat turbine. But are very big power stations and they can't fly. How can we bring them to an aircraft? In the middle of the slide, you can see a schematic diagram. We want to get water out of gas. The water is condensed and it is a boiler. Then it is led to the combustion chamber, and so the turbine of the gas turbine also works as a steam turbine. We get a lot of more power from this turbine. And the big advantage that we use forced heat, and therefore the efficiency of this is very high. There are two other big advantages. The first one is that because the water injection will be very low, and the third is that in the exhaust gas is water vapor, because we condense the water and there will be and assume that the contracts are that we will get less contracts. So that the climate impact of this engine is much lower in comparison to conventional gas. But of course, there are big problems. Again, please. No. Yes, thank you. There are big problems. The condenser you have to integrate it. This will be a very because it's a component. And we have started a ground demonstration program and in cooperation with the DLR.
I think we do have a few problems here, technical problems with the slides and the voice. So while the colleagues in the technique are solving these problems, I in between go to our last person here on the board and actually with us in the room, and then come back to Mr. Sieber from MTU again. So the question goes to Nico Buchholz. How do you see the chances of all these new products on the market? Does it take other stakeholders, or will airlines easily take up these new types of products?
Thank you. Thanks a lot for the question. Well, I try to answer that because that's the multi-billion-dollar question. This is a very green slide now. My view, due to my past, will be more or less 360 degrees. So I guess your question puts me as a grain of salt in the equation. And the grain of salt in this is, one is the monetary side, which is a challenge. But the other one is actually salt is a spice and it will produce a better result in the end. So let me go to a couple of things, your question. And I'd like to start just with the simple thing is, apart from government funding, the only cash which comes into our system is the airlines. And the airlines then will filter down into the river which feeds us all, which is the airports, the leasing companies, and everybody, the fuel companies, everybody who's involved. And I will not read all the slides, but you can also take some of the points afterwards. So if I go to the next one, I think the challenge which we are facing today, looking at the monetary side, we have been spoiled in aviation with technology creating a lot of cost reduction. I take 25-year steps with 150-seater aircraft on this slide. From a 727, we came down 25% in unit cost on the 320. The Neo only gives 5%. Admittedly, 5%, which are very important because they are basically all coming from the environmental footprint reduction. But at the same time, knowing that these technologies and cost reductions have triggered the growth, we have to look at what is next. And next is we're currently focusing on global warming or CO2 reduction, knowing that we need a holistic approach, as some of my previous commenters have said already. And so we need a global approach. And a global approach really is something, let's look at aviation. Like, there's many bubbles around the world who want to create something as an alternative. We do have aviation. Let me just pick a couple of things. There's no real choice for urgent cargo. And actually, the crisis has shown us that. There's no real choice for long-haul traffic unless we take a long, long time off. And we have a globally very fragmented view on air traffic. So in the past, fuel was just a cost element. I'm a bit provocative on that, but I think for most of us in the industry, it was just a cost element. We became environmentally friendly by saving fuel, but it also hit the balance sheets. Well, if we look at tomorrow we have hydrogen, we have fuel cells, we have many other options. And those options need to be assessed properly in order to be affordable, and they need to be embedded in a global policy, because we cannot anymore create an environment by a certain region of the world or by a certain company. I remember times when there was the noise perception, just to take one. Apparently there was lots of different ears around the world when you looked even at Germany, France, the US and Asia. And we can't afford that split anymore. And so if I do a short outlook, we can't waste time today, because if we want to hit the next cycle when actually aircraft need to be replaced, then we have about 10, 15 years or so. And looking at the lead times which we need, that means a framework and the whole studies need to be leading to a globally agreed element within the next very few years. And the key is, there is tons of technology, but coming back to your question, who is paying for it? And paying is a passenger, and we cannot just reduce the travel, because travel is not only going to the beach, travel is also cultural exchange and very many exchanges which make the world a better place. And we need to avoid some of the mistakes, because we had, not too long ago, suddenly CO2 was overruled by NOx in certain areas of the world. Some manufacturers created something which was NOx focused, created more noise and created more fuel consumption and CO2. These things cannot happen anymore. We do not have that luxury anymore. And so the key message is really, we need all of these, which I've listed here, money, technology. We need a lot of communication, because today we are very aviation-centric. If you go to the street, very few people know how much good things various organizations have created. And that is something which needs to be done, because that will then also lead to a cost mitigation at a later point. And with that, I'd like to thank you.
Well, thank you very much. A lot of interesting topics, and we will come back to that, I'm sure. Now we go back to Jörg Sieber from MTU, who has been interrupted, and please go on with your presentation.
Yeah, let's start again. Oh, there is a... You can go to the next slide. In the last year, there was an increasing interest in fuel cell. The fuel cell is a chemical cell that converts chemical energy of hydrogen and oxygen into energy. And electric power is of course used to drive an electric motor and to drive fans or propellers. Problem today is that power density of the fuel cell is low, and there's another big problem, that the cooling of the fuel cell, because there is very little difference between the fuel cell and air. So it's one of the big problems to be solved. But on the other side, we have no emission, with the exception of water. And so that is the solution for the far future when we want emission aircraft. Together with ACARE, we are just starting a project, a flight simulator, on year 2008, where to replace turboprop engine by a motor and the system. Next slide. On this slide, you can see our mission flying. We start top right, and our gear turbofan with the next generation, we use the fuel consumption by 10%, something like that. Not a big step. It's not enough. But if we use sustainable aviation fuel in this engine, we can reduce the climate impact, and we can reduce the health impact too, because the particle emission will be lower. And the next step is our wet engine, the water-enhanced turbofan, which I had presented at the beginning. Here we have a very low energy consumption, a significant lower NOx emission, and a reduction of the particle emissions. Both of these engines can use hydrogen too, and with hydrogen we can improve the situation a little bit, because with hydrogens we will have no particles in exhaust gas, and we think that also the contrails are less. And the last step will be the flying fuel cell, where we have no CO2, no pollutants, and no particle emissions. And I think that we have to offer the society such an engine before the year 2050, because everyone on Earth is going in the direction of climate neutral industry, and we as the aviation industry have to do it too. Thank you.
Thank you very much. So we did it. We went through the first list of questions and the presentations. Thanks to all of you. And now we start with the discussion of this panel. And I cannot resist starting with Nico Buchholz, and I couldn't agree more to your last two slides, but being a bit more specific, I mean, even in the last 2 days and probably also tomorrow, we have many different talks about decarbonization or climate neutral or emission free or sustainable or environmentally friendly. So these are all somehow different, and you also addressed it. Do we need a year-long discussion among all stakeholders, or should somebody stand up and say, well, we go for decarbonization? What's the way that we have one single goal?
I think the key question there is, we need a global policy because we cannot avoid it. If we do that global policy completely bottom up, it won't work because it will take too much time. we will need to give a certain guideline, a political framework. We had some frameworks in the past. We need to re-establish frameworks which actually point into a certain direction based on the technology research which is done by all the companies, because then we can have an infrastructure to take the stakeholders with us, because the stakeholders are airports, refueling companies. The airlines need a certain standard, because you cannot fill at one end of the flight, you fill it with hydrogen, and on the other one you fill it with kerosene, and then the third one you want to fly it on batteries. Those things are operationally not manageable, and therefore we do need a global infrastructure.
Thank you. So we still have a missing link somehow on our way towards 2050. Anyway, touching another issue, we haven't talked too much about it today. Has been mentioned, but not in depth. To Marco Protti from Leonardo. So making use of all these new technologies, I think it would ask for a certain new design to introduce fuel cells and then new engines, whatever, and opening the design space and thinking design through up to certification, maybe even virtual certification. We need much more digitalization of aviation. How far is Leonardo in this, and how do you approach this topic of more digitalization for the sake of environment?
Yes, I fully agree with your statement. The capability to comply, so there is a huge echo. The capability to comply with this new paradigm imply to be able to reach a level of digitalization in our process, including not only the design, but the full life cycle of the aircraft, including the phase of certification that is one that is more complex, because we need to face at the same time the capability to comply with the new regulation environment that will probably needed to introduce this new technology in the product, and at the same time to provide to the certification authority the possible evidence that this virtualization of some part of the certification is as relevant as physical testing. As far as Leonardo, we are started a roadmap since some years in which the goal is to reach a full digital twin concept implementation in our product development and sustainment, because in our view, this is the only solution that at the same time enable to compress the development time for the new product, and at the same time to keep them affordable, because as you already mentioned by some of the other colleagues, we cannot afford to present to the market a solution that will far from the current one in terms of not only acquisition cost, but also operative cost.
Thank you very much. Next question goes to the other engine manufacturer, to Pipistrel, to Ivo Boscarol. I think we see more and more that technology and technology breakthroughs are really starting with smaller aircraft, which is good news for you also. On the other hand, the general aviation market is normally dominated by price, not so much on technology and sophisticated technologies. So will the stake of the future be more on the technology side in general aviation or more on the price side? So where do you expect the things to move?
Well, you know, I'm coming from real world and not from the future, what will be tomorrow. Okay, we are working on this, but we are facing today the situation on the market, delivering 4, 5, 6 aircraft per month. And the real problem is not where and how we can improve the technology. The real problem is how the final users, how the regulators, and also like insurances approach this progress. You know, today it's not easy to find an insurance who will insure a type certified electric aircraft. You know, everybody is afraid of technology, of new technology. So we must endorse also the brain of the consumers. And if we don't assure the market first, then all the technology, all new products we will develop will be useless, because we will not have the return from the market to develop new products. Imagine that our aircraft can be, even if it's type certified, can be sold only in EASA member states. We cannot sell it in US because the standards are different. We cannot sell it in Canada, in Brazil. You know, the regulatory institutions must start working globally to assure the standards. Make no sense to develop the best emission-free hydrogen propulsion if nowhere will be able to use it. In private pilot license is still written, you know, it's single pilot engine license, but our aircraft don't have any piston. So EASA has done enormous work here, but we must assure a global market. And then, of course, yes, also like small producers like Pipistrel is engine producer. We are now also engine producer for our other airframers, for other manufacturers. But if this engine is type certified and you cannot install it, for example, in another part of the world in one aircraft, because there are no rules there, then we all have problems. The regulators must start working also on, let's say, some penalization if the, let's say, aviation will not be emission-free, or with motivations. So we must assure the market. The market is crucial for all we are talking these 2 days.
Thank you very much. So the first questions come up on the screen, which just disappeared again from the audience. So I continue with a few questions I prepared, but maybe we come back to a question from the audience later on. No, here we are. So this is quite an interesting one, and from the name it sounds it's coming a bit more from the eastern side of the world. The question is, let's go to Siegfried Knecht, I would say, from AREG. How can the EU persuade other countries to invest in SAF, in sustainable aviation fuels infrastructure, so that airlines can really use SAF in operation outside of the EU?
Well, yeah, thanks for this very interesting question. I would say the European Commission needs to come up first with the proper regulatory framework, which, as we all know, is in preparation with the Green Deal and maybe mandates and this Refuel Aviation initiative. So I would expect that the Commission is coming up with this regulation. And on the other hand, what we can see is investments already taking place. If you take Neste or Shell, KLM, Sky Energy in the Netherlands, Total in France, Velocis in the UK. So there is already investment going on. And of course, the Commission or governments also need to provide funding in order, to ease the introduction of the high-priced SAF. And my personal hope is that this time we all together do it right, because as we remember, with the Flight Path 2050 or the Biofuel Flight Path 2050, the goal was 2 million tons by 2020. So we are in 2020, and as I said earlier, today there is only a few tons available today. And so, well, I guess there is a chance in Europe, to get ahead, together with other parts like the US or of course, also in Asia, where in Asia there might be an issue, at least with feedstocks, Europeans don't love. But anyway, I guess we are all, towards the same goal, and I would expect that the Commission is coming up with the right proposals. Thank you.
Thank you. I have another one to Rob Watson from Rolls-Royce on the duration. We have seen this famous slide from, I think it was from IATA on the how we come to carbon neutral growth and how do we cope with CO2. On the other hand, CO2 has a very long lifetime in the atmosphere, a couple of 100 years, if not 1,000, while all the non-CO2 effects have very short lifetimes. So it could be easier to do something with the non-CO2 effects than on the CO2 effect. How do you, at Rolls-Royce, how do you rate this? Shall we concentrate on the non-CO2s or more on the CO2s? How do we cope with that?
So I think we would take a holistic view of the whole challenge. And I think really back to Nico's point, what's the language that we're using? I think that the important focus that we have has always been on how do we improve our emissions. And obviously that covers NOx, CO2, it covers noise, and we have a duty to use our engineering talent to drive all of those as much as we can. Clearly, like you say, that that CO2 challenge is a significant one, and why you have such a strong focus on decarbonisation. And I think that's why we've always said we think SAFs have a major role to play. But we do think, I think the final point on my slide around emissions and sustainability is just understanding what problem you're trying to solve. And at this moment in time, I think what's exciting is there are routes to address every single part of the challenge. And I think I'd just echo what the other panelists have been saying. This is all about a consolidated, coordinated, sort of not simply an industry-wide approach. It's also that governmental coordination that's required, so we can align on the right technology roadmaps, and we can put the regulatory framework in place to address it. And we have a commercial framework, which means it makes good financial sense to do this, to deliver substantive change. So of course, we're always going to have a strong focus on decarbonisation, but equally, where we need to drive our effort is all around just reducing emissions from our products, and what can we do to address that challenge.
Thanks, Rob. Before we go to some question from the audience again, question to Jörg Sieber from NTU on the long range or on larger aircraft. I mean, when talking environmental optimized routing, lower speed or lower altitude is no longer a restriction. So the question is that in the future, will we see larger aircraft being driven by propellers? So what's the future of long range aircraft? Where is this heading to?
I don't know.
Next question then.
In Bauhaus Luftfahrt, they made a very interesting study, a long-range aircraft driven using hydrogen, and the speed was reduced a little bit. And the idea was that the passengers have more comfort on the airplane, and that they love to stay in this aircraft. But I really don't know how we will go there. Maybe refueling in the air is a good solution for long-range aircrafts, because the weight is a big disadvantage. If you carry hundreds of tons of kerosene or hydrogen, this is not very good for the aircraft. And if you reduce it, it would help a lot. But I think the first step we as a community have to do is that we have to introduce sustainable aviation fuels, because that's the only way how we can reduce the climate impact of aviation at once. And the later steps, they are unclear. That's right, because if we want to hydrogen, we all have to do it. It makes no sense if we have hydrogen only at a few airports. But the first steps for me are very clear.
Okay, so having heard all this on how we proceed with SAF at once could mean a decade or something. But anyway, next question from the audience is a bit on, and it's going to Ivo Boscarol from Pipistrel on the infrastructures. And the question is that at least in Germany, more and more small airports, airfields are closing. I read that Munich, example of Munich, there's no more general aviation airport in the vicinity. And this happens all over Germany. Of course, they cost money and intend to close it. I assume that the same is true, at least in Europe, if not worldwide. So how do you think we can overcome this so that we can use your aircraft in the future?
Well, here there are two things. First of all is that in Europe there are every day more, and if my number is correct, we are approaching 130 general aviation airports which are closed because of noise. The community is complaining because of noise, and especially during the weekend, it's not possible to make any more training, only during the week, and nobody has time during the week, so there is no business case behind anymore. And of course, destroying new agricultural land for new airport, it's everywhere a big opposition. So that's why I was telling also in my presentation that we must bring the airports closer to the passenger and not passenger to the big airports. The aircraft must follow the direction that the needed airstrip or the runway will be shorter. So short takeoff and landing, of course, means also to diverse or to go in a different concept of the aircraft, not let's say to hundreds of passenger aircraft, what is needed of course for long distances, but to feed the airports and to offer the service as close as possible to the passengers, to allow first of all general transport, passenger transport to smaller airports, and to make smaller shuttles like mini liners, microfeeders, to bring the passenger direct from a small maybe grass airstrip to an international airport, not forcing him to change car, bus, maybe another regional aircraft. So this is a missing link now. And small aircraft industry already now has all this know-how and knowledge how to do it. And to start running, you must start walking first. So why not to focus on what is available in this moment and then to go towards bigger goals?
Okay, thank you very much. Haven't received much from the audience, so I continue with the questions to our round here, and especially now again on because talk energy transition on the engine. We haven't heard very much about LNG, liquid natural gas, in this round here. Rob, could you comment a little bit on where are we in terms of LNG for big engines?
I have to confess here that by the time we're into discussions around alternative fuels, it's probably outside my technical remit. So I don't have a view on LNG. I mean, obviously, our focus, as I said, has been how can we progress SAF, and obviously we need to evaluate and understand hydrogen as a fuel and what the opportunities may be presented there. So really for Rolls-Royce, those are our areas of focus today and going forward.
Okay, I would like to pass the same question to MTU on is there any, because we talk much about SAF and hydrogen, not so much on other solutions like LNG. Is there anything in the portfolio of MTU in this direction?
No, we don't have it in our portfolio, but of course it's possible to fly with LNG. If I remember, the Russians, they flew in the late 80s with hydrogen and LNG. And we had a LUFO project 10 years ago, something like that, where it was where they looked into the tanks for LNG. I think it would be possible, but I don't think that it makes very much sense, because it's nearly as difficult as to fly with hydrogen. And where can we get this LNG? If it's fossil, we also have the problem with CO2. And if we produce this produce it by renewable electricity, we first have to produce hydrogen, and then I think it's better to use hydrogen. And I don't think that it's a very good idea to use LNG in aircrafts.
Okay, thank you very much. We have another question from the audience related to standards. So the question is there a parallel running effort to create technical standards for the usage of the emerging technologies related to the zero emission goal? I think this could go to Nico Buchholz. Sorry.
Thank you. I think that there is technical standards, but they are currently still very fragmented. What we see around the world is a fragmented standard. And so the question is, I really don't have an answer for it, because there is no worldwide standard yet, except that everybody agrees to reduce global warming.
Fair answer, thank you. I would like to ask Marco Protti again from Leonardo on these different changes, and if we go for hydrogen forever, what do you think the configuration, the aircraft would change? Do you have already designs in petto that you say if we use hydrogen it will be I don't know, blended wing body, if we use batteries we have something else? So what's the repercussion on design of these new technologies?
Yeah, the impact on design is one of the challenges that we have to address. In our understanding, we are exploring different trade-offs in the configuration, and our goal is to identify configuration that keep the flexibility that characterize the regional aircraft, together with, of course, the need to integrate a solution that is very specific. For example, if we talk about hydrogen itself carry on a set of specific requirements for the storage on board, for the distribution to the engine, that will affect. Our goal on the other side is to try to compensate some of the penalties that could be associated with the introduction of the hydrogen, but more or less the same level of penalties could come from, for example, an hybrid solution based on batteries or on fuel cell, with some different improvement that we allocate to the global aircraft architecture, from, for example, the configuration of the wing and so on, in order to get at the end a balanced solution that is capable to deliver the performance that at the end is the key factor that will drive the acceptability of the new product for the market. Because at the end, the market has to use a product that is capable to be operated from the current airport in terms of field length, of services, and also the MRO should not be changed so fast, because it's a very, very complex organization that, on the other hand, is the basis for the safety record that are related to the aviation. So the capability to compromise design of new aircraft with the challenge to comply with the basic system requirement is still an ongoing effort.
Okay, thank you. Before we start the last and final round, I already announced that I will ask any of you to give a final comment on this, our topic of this panel on the energy transition. I have one last question from the audience. It's directly to the MTU. So the roadmap of the wet engine and the flying fuel cell concepts, you already mentioned the Dornier 228. Do you have any other platforms or aircraft for testing these concepts, Mr. Sieber?
At the moment, not, because it's already very expensive, and we will focus on these two directions: ground demonstrator for our wet engine and a flight demonstrator for the fuel cell.
Okay, thank you very much. So the time is already almost running up. We have a last quarter of an hour, and this should be devoted to the final statements of our panelists. And I would like to start with Ivo Boscarol from Pipistrel to sort of finally address the topic of energy transition. Could you please give me your thoughts?
Well, energy is connected to propulsion, that's for sure. In the past, we had piston engine, then we had jet engine. Now we are everybody's talking about electric engine. I believe in future the next milestone, the fourth milestone, probably will really be hydrogen. Yes, because we are close. Everybody, we say that we are close to use it in aviation. Of course, the standards should be made, and the worldwide standards that we will know then how to design our vehicles, what would be the possible real use. But of course, energy, it's a very tricky question. You know that there are, let's say, institutions working on this ionic propulsion, on different propulsions. But I believe electric energy, somehow in combination of kind of hybrid, is the one which we can really promise results in the next decades to decarbonize the aviation, to make it emission-free, climate neutral in the real time, that we can promise to the end users that we will offer to society a way of living and to be satisfied with the clean atmosphere. Hydrogen in combination with electricity is the reachable next step. And I believe in 2050, we can not only dream, but we can, the industry, I believe with the regulators, can assure at least regional transport, which will be climate neutral on hydrogen and in combination with the electricity. What the future then will bring us, how we will be surprised with new energies, maybe magnetic, I don't know. This is always necessary to keep in our dreams, because without dreaming there is no process. And but we must be with two legs strong on the ground now to offer what we can do.
Thank you very much. You have almost eaten up the time of the others. No, not really, not yet. So about, if you stay within maybe a 2-minute slot, that would be very nice. So we continue with Marco Protti on energy transition. So what's your final thought on this topic?
Okay, thank you. We are now in the middle of the decision process. We have not yet a solution that will comply with all the constraints, with all the regulations that are necessary in order to speed up the development of new products. We are still in the area in which technology roadmap are needed to consolidate through appropriate down selection the solution that will become the standard for the future. And the standard should be compatible with the full chain, the full ecosystem that affect the proper function of the aviation system. And for me, the example that is now driven by the Clean Aviation Roadmap and the commitment that the 29 stakeholders have set with the European Commission to invest up to 3 billion to mature and demonstrate technology that will create the solution in terms of technology demonstration, and so to enable the generation, the future generation of aircraft, is the best example of the approach that the aviation sector have taken with respect to the transition, energy transition problem. But we need to be realistic to the fact that the jet fuel will remain for some years still the reference for the air mobility.
Thank you very much. From the view of AREC, energy transition, where do we go?
Well, I do have one message and two recommendations, if I may, and I'll be short. The message is, or the message goes mainly towards politics, but also to all the stakeholders engaging in the production and deployment of sustainable aviation fuels. And it is, why wait another 10 years for the advent of PTL if today already we have SAF available, or SAF will be available in higher quantities within the next 2 or 3 years. And as we all know, SAF being made available in this time frame is capable of reducing CO2 emissions by 80%, sulfur compounds, NOxes, but even more important for airports, particle emissions. And the two recommendations refer to 2 papers. One is a roadmap which my member companies and institutions produced over the last couple of weeks, which is a roadmap for the introduction or the production and deployment of sustainable aviation fuels in Germany. But being humble, I would guess it could also serve as a blueprint for activities beyond German borders. And the other one is a paper being produced by a coalition called Clean Skies for Tomorrow of the World Economic Forum, called Sustainable Aviation Fuels as a Pathway to Net Zero Aviation. There are even more, companies and institutions involved in there than we have in AREG. And so I guess, if politics would certainly, or just, take on what's in those papers, we could make a big step forward. Thank you.
Thank you. That has been true for decades anyway. Okay. Rob Watson from Rolls-Royce. Energy transition for Rolls-Royce means what?
So I would say our focus is going to be on SAFs for our core business, but it is all about the enabling ecosystem around it, whether it's a focus on whether there's sufficient feedstock for SAFs, the different routes to create SAFs, or whether it's around the other enabling technology and opportunities, whether that's electrification, hydrogen, whether fuel cell or as a liquid. It's a hugely exciting time, but we do need to focus on making substantive progress as quickly as we can. And so for us, that's front and center with SAF.
Thank you very much, Rob. And the same question, of course, goes to MTU. Energy transition. The answer from NTU would be, Mr. Sieber.
At once with sustainable aviation fuels, with synthetic kerosene, and as we can produce it from biomass today in bigger quantities, we have to use it. The only problem is the price. It's much more expensive than fossil fuels. And so I think we have to introduce a quota in Europe, or hopefully in the world. That will be a big problem, of course. And yes, we have to start with biomass-based fuels. And as we can't produce the whole demand of fuel by biomass, we have to switch over to power-to-liquids fuels later, and maybe in 20 years we will switch to hydrogen. But that's a much bigger problem, as we have to build up a new infrastructure.
Thank you very much. So, of course, the last in this round, Nico Buchholz, I mean, you are sort of independent. All the others have a company they work for. As an independent advisor, your view on energy transition of the future of aviation?
Well, I come back to something, picking up on some elements. We need one voice and one face. And the face, let me drop out of the aviation. What is the face of electrification in cars? I'm sorry, I do drive a German car, but the face of electrification is Tesla. And we do not have that in aviation. So we do need that one face. And the face is not, as I said, a physical face. It could be a company, it could be a product. It's like something which creates a standard, which is comparable. A standard means, by definition, also a compromise somewhere. But therefore, we would move forward. Otherwise, we would still not have our mobile phones, because I know next week there will be a new one coming out, which will be again better. So we need to move ahead right now, and ideally using most of the infrastructure, because we have a lot of cost to shoulder, we have a lot of technology available, but using today's infrastructure would be a definite plus. And I relate to whether that's airlines, manufacturers, or airports. And we can only reach it when you're really focused on it and not waiting for somebody else to come up with something. Like, let us focus, and then we achieve it for the next decade.
Thank you very much. That was, I think, a really good roundup of the session. So my job is almost done, and I hand over to our moderator, to Conny, please.
Wonderful, and I'm trying to get in and be both socially distanced and internally, of course, very close to your subject. Thank you all for this absolutely fascinating discussion, really rich in arguments, and thank you very much also for your optimism of getting things done. And I know a number of you have been on the issue, with the issue, for the issue for many, many years. Maybe we really get traction, and maybe this year 2020, despite the fact that it's been so horrific in many ways, will be the year in which we actually see a turning point. So with that, ladies and gentlemen, I would like to thank you all. For everybody who is watching us now, you all have not just a break. Of course, you can have a break anywhere and any time when you're watching us digitally, but you now have the opportunity to meet and greet Professor Rolf Henke, who is just being whisked away into a different room simply because we're really here live and physically. So for him, it's actually a walkover to the meet and greet room. For everybody else, it's a chance to have a look at the exhibition. And we're going to be back online with the next big session, with the next 90-minute session at 14:45. Then we're going to talk about the digital transformation, which is, of course, the other underlying issue. And I'm quite sure that in many ways there are similar arguments, and actually they're intertwined in order to find the right solutions. And with that, do enjoy your lunch break, whatever you do. But it would be lovely to actually explore the offerings on the website. Talk to you then. Bye.